Hello and welcome back to the development of the Feersum scheme compiler. So in the last stream I think we pretty much wrapped up the implementation of lambdas. So lambdas can now be passed around on the stack, called with all of the different argument patterns that you would expect from the scheme spec. And in between that stream and this stream I actually fixed a little off by one bug that was causing array index out of bound exceptions. So today's stream, the plan is to try and do something a little bit simpler and just look at implementing some more of the comment forms that the R7RS scheme specification defines. So I think we'll start, like we usually do, by going over what we did last time, and have a look at what the plan is for today. So in the last stream we worked in the compiler to support the to implement this unpack remainder method. So unpack remainder is when we are building the kind of like thunk or the shimmy thing that we use to create our system.func instances that we pass around as our lambdas. We use unpack remainder to turn all the rest of the arguments that have been passed to the function into a scheme list. So the idea is that it walks through that array and turns it into a list of cons pairs, and we have to emit some IL code that will do that loop. And so at runtime it will walk through whatever the array is that it's been passed. So it has to do some bounds checking to make sure that the array is at least big enough to have the parameters in that we expect it to do. And then the unpack remainder method's job is to loop through, and effectively it starts off by pushing a null on the stack, and then it successively reads the next element out of the parameters array, and then it has two things on the stack, turns them into a cons pair, and then it has one thing on the stack, and it just keeps on doing that, creating a list of scheme list which is made up of cons pairs. So the way this basically works is that we get the length of the array, we store that because we're going to need to reference it in the future as our index variable. We create our null, which is our initial empty list, and then we jump in immediately. We jump to our condition, which is something that we didn't do at the end of the last stream, but now we jump into our condition check. We check to make sure effectively that if we were to read from the array, it would still be in bounds. So we do, if we are still in bounds, we jump back to the top of the loop, we load the element out of that slot in the array, call the constructor on the cons object, right, a cons pair, and then check if the next element would be in bounds and loop through, and eventually we'll drop out of the bottom of the loop, and the element at the top of the stack will either be the null, the original null if there was no arguments, or just a list of cons pairs, so a proper scheme list. So, job for today is, if we have a look at our spec tests already, we have a set of comments, and at the moment we support single line comments, so you can have one semicolon, it doesn't matter what white space you've got, how many of them you've got on one line, or anything like that. Any of that stuff is commented out. But in the scheme specification, I'm just going to bring that onto screen right now. In the white space and comments, it talks about this semicolon, which is a single line comment, but there is also a way to comment out datums, and which is a hash and then the comment character. And the way that works is, instead of it commenting to the end of the line, it basically passes a form, which is either an atom or a list form, and then just comments out the whole thing. And the other one is this nested block comment. So you do hash and then a pipe character, and then these nest properly. So if you were to then put another like hash and pipe somewhere in here, or maybe around integer, it wouldn't, the uncomment, the pipe and then the hash, they're counted as like a stack. So you'd be able to like comment out whole regions even if they contain block comments, and then safely uncomment them later. So I think the first place to look is just at the datum comment, because it should be simpler to implement. And it might actually be a good idea if we take this example program out of the spec and put it into our test so that we have something to reference. So we will create a new file and we'll call it comment extended. Wow, that's not gone very well. How can I copy this properly? Just gonna have to do it manually, I think. So it defines fact. I'm just going to move this over so that I can see it on the right hand side. So it defines fact as that lambda, which takes n, and then it does if n equals 0, and then there's a commented out if n equals 1, then it returns 1, it says base case return 1, and then we do multiply fact n minus 1, and there's a whole load of closing braces. Good. Right. So, first off, we'd like to support this. So I'm going to create a test case that just contains this part here. Well, yeah, we'll create a simple test case that just contains the 1. So I'm going to go and do that inside the syntax tests directly, because it'll be a little bit easier. So parse atoms, identifiers, we'll have maybe a datum comment test, maybe. Can just make it a facts test because we're only testing one thing. So passing a datum comment, and we would expect a literal number and 1, and we're going to do read single, and then that whole string, which does that need a no? Assert.equal is uppercase, yes. Number is a float, so that needs to be 1.0. And now if we run our tests, that should fail. So we've got two failed tests, and one of them will be the new spec test that we just added, and the other one is the fact that we haven't got a snapshot for the comments extended scheme. Error in comment extended, yeah, expecting blah. Has that worked somehow or other? It shouldn't have worked. Oh, I haven't saved the tests. I'm so used to the fact that the C# extension saves the test, saves the file you're working on before running it. Or is that an Emacs thing? I was looking yesterday at Doom Emacs. I've used Emacs for quite some time now, but I don't tend to use it in day-to-day development anymore because, well, mainly because VS Code's just so good. But it'd be nice to use it for more things. Doom Emacs looks like it is very well styled, so maybe that'll if it has working LSP mode and things like that, and you can get IntelliSense for things like, well, I think it should support F#. I've seen there's a LSP mode plugin for that. It'll support Rust. I think the main pain point is the fact that you can't run the .NET debugger. So, has this genuinely worked? I mean, I've got the parse results. Snapshot does not exist. That's fine. I know that one's a parse error. What I'm going to do is I'm just going to rename this file out of the way so that the spec tests don't run it at the moment. So I think that if I run the tests now, it's not going to find that because the spec tests work by just globbing for anything that's got SCM at the end. Yeah, that's all worked. Test parse results. Extended identifiers. Escaped characters. Extended identifiers, literals, atoms, empty program. Parse results. Oh, of course, because it's not a function, so it can't call it. That was silly. So instead what I'd done is define something that at compile time, well, at static initialization time, set this identifier to this expression, but yeah, that's not very useful for unit tests. So that fails. So the place we'll be working on this today is in the syntax. So we have so in parser combinators, we basically build up the parser from a variety of different functions, which are themselves parsers for smaller parts of the language. So what we want to work on here is this parser, which just deals with comments. So the way it works is it's a parser. The state is unit and the return type is unit. So it basically takes no, it has no parse state, and because none of our parser has any state yet, and the return type is unit because it produces no value because comments have no value. I mean, comments have value to the people who are reading them, but there you go. So we've got the single line comment, which just, if it sees the character semicolon, skips that, and then skips the rest of the line. And skip rest of line true tells it that it's something to do with new lines, I think. Anyway, so the plan here is that we will, let's make these all functions. So we'll go let single line. So a single line is if you skips a character and then skips the rest of the line. We'll also have let datum. So a datum comment looks like skip string, it's a hash and then a semicolon, and then I guess we want to pass the whole of an atom, or is that a whole of a form? So at the moment we create a parser forward declaration a bit further down already for the form. So if we move the forward declaration of the parser all the way up to the top, we can just say pass, skip the string, and then pass the form. And I think there is a parser called skip or ignore or something like that. But to be honest, what we could actually do is we could just take the unit value from the left hand side, and then our final parser for a comment becomes single line or datum. And the return type of that parser is still unit. If we run the test task again, we should see that unit test pass. Fingers crossed. Get this back up again. So that works. So in this unit test, if you've got the hash and the semicolon, it will ignore the rest of that datum. Let's do a few more tests in here and just check that it works. So what happens if we don't have the new line in there? If we just have the 1, does it still return 1? I mean, you'd expect it to. Let's just check it's returning the right thing. And I will also check that commenting out a single like number or something like that would also work. I'm not sure whether or not this is getting complex enough to start moving it into a theory test, but I think it kind of reads a little bit easier at the moment like this. That still works. Good. And let's just go and review what we've done in here. I think we just, yeah, clean up the white space a little bit. Just gonna change this to use the simpler. So just cleaning up that parser a little bit. This is the actual parse form parser. So the way that fparsec works is that up here where we do a forward declaration, we get parse form, which is our parser type, which is what we're going to use in the other combinator parsers. And we get this parse form ref, which is immutable that we can then write to later. So you can have parsers that are recursive or mutually recursive. So when we write to it here, we're effectively saying the body of parse form when we actually call a parser will be this, which is the between white space application or atom. Okay. I'm happy with that. So we'll stage the syntax and we'll stage the tests. Just going to review what we have done. So we moved the forward declaration to the top. We've added the datum comment type, and down here we have just simplified parse form a little. Datum comments, use the hash semicolon prefix and skip the whole of a following datum form or atom. Good. Then the next question is, what about those block comments? So you can go and just add another syntax test for those first. So if we pass some block comments, I mean, again, we can do number on and we will do a comment. This is a, and then we will just have one at the end. And we can also, oh dear, that's not going well. We can also have the one at the beginning, and we'll see how far that goes. So we're not doing anything with the nesting yet. So this test should then fail. And this is where going to have to have a look at the fparsec docs again. So we can make that test pass initially by just going into syntax, and in our comment parser we can have a parser for block. A block parser is well, we could use a between parser for this. So we say between, and then you tell it the two parsers that you want. So the left hand is going to be a skip string, and we will skip the opening comment. We will skip string the closing comment, which is the bar, and then the hash the other way around. And then the body, we can probably, we could go skip so we could do skip none of. So what we effectively want is we want to skip anything that isn't a closing comment. But skip none of takes a skip none of takes a list of characters to ignore, but if we just used skip none of and passed in like the bar character and the hash character, then you'd have it so that you wouldn't be able to use them inside your comments, even if they weren't paired up as an actual comment, if that makes sense. We can do that for the time being though, and it will make this test pass. What it might be, yeah, I think we need to use a little bit more brackets. What we might need to do is have like a block body parser, and then the block body would be like an alternation of anything that isn't a hash or an opening bracket, and then if it is a hash, we've got to deal with increasing the nesting and then running it again. And if it is a bar, then we basically don't match it, and then, or if it's a bar followed by a hash, sorry, then we basically ignore that and finish off the parsing of the comment. But this should make this test pass, and then we'll add another test in for the nesting of block ones. That should prove why this is not quite correct. Oh no, it didn't pass. Expecting floating point number, identifier, or white space. Ah, because we don't actually use that block parser. Fair enough. Again, block. Let's run that test task. Yeah, restart it, please. Still not passing. What are we doing wrong? Expected a single expression. Got error. I said it's expecting so it's failing to pass it here. Right at the this. And it's kind of like it's not able, it's expecting to pass, it's expecting the closing comment. Because this doesn't match. This parser only matches a single character. We want to do many. Many skip none of. That's now a. So we go skip many. And then we ignore the body. Right, now, finally, we should be at the point where, even though we're not doing this properly, the unit test passes. Just running the unit tests, and it passes. So, time to prove that we're not doing this right. So if we've got a simple comment, that's fine. What about if? What about if we have a nested comment? So we'll start out with this is, and then we'll have a bar, and then what I would expect to happen here is this test will fail because it'll pass this, and then it's going to skip none of, fail here. That's not going to be the closing thing, and so then it's going to go right back to the beginning, and it's going to fail the pass for the whole thing. I mean, it's going to fail in one way or the other, because either that, or if you did fudge it so that this was ignored and it was only looking for this, it's going to fail because the nesting means that you actually need to ignore all the way up until this second closing block. But yeah, expecting any character not in that or the closing. So It didn't fail in either of the two ways I expected, but it still failed. So that's good. What we will do then is extract out a block body method. So a block body at the moment is this, skip many, and so on. No. Cut that with the wrong. I use Control K there, and so we've ended up with there losing the copy and paste buffer. Right. Read block body. So we have skip many, we have skip none of. What we really want to do here is a choice, because there could be the three things that could happen as a character inside your comment is you could have a choice of, you could either skip many characters that aren't to do with block commenting, you could match a well, what we really want to do here is we want to be recursive. So we want to say inside the block body, you could either have a block. To do that, we need to do a forward declaration of the parser again. So we'll say block body or block ref. Create parser forwarded to ref. Then we can set the block ref later to our body parser. Inside our block body, we could either have a block, we could have anything skip not. If it's not a it could be anything, you can have as many as you want as long as it's not a bar, or you could have a bar followed by anything that is not a hash. That is not a character. Fair enough. Let's see if that works. So the way this works is we're not using any parse states or anything in our parser to try and keep track as we go through of how nested we are in the comment, we're going to try and use the actual call stack. Expecting any character not in bar yes, so that needs to be skipped none of. So we want the trouble there is that when we did skip, we matched this, we skipped all the way, and that's not a bar, so we skipped to there, and then we failed because this isn't a closing comment. And then I guess we will need another version which is saying, so a bar is fine as long as it's not a closing comment, and a hash is fine as long as it's not opening another comment. Although I think by this point we know that we can safely skip a hash, because if it was an opening comment, block would have matched. Yeah, I think that's fine. It wasn't fine. What went wrong? Expecting any character not in that. Did I just not save that properly? Oh, of course. This needs to be a skip many. Because there could be more than one of these types of things inside the body of a comment. And this block body would only skip one type of thing, either one nested block comment or many characters that aren't the closing thing, or a pipe character followed by something that isn't the closing comment character, or a hash. To a parser that succeeds without consuming any input and without changing the parser state. So this needs to be at least one character. So the actual body of the comment itself, we're using skip many because we don't actually mind if there was nothing in the comment. But if parsec does mind if you nest that so that this block body should match, every one of these should match something. So the block matches something because it's got the opening and closing pair. Skip many one. What are we doing now? Expecting a character not in hash. I actually ended up making an earlier one fail. So I think it's saying it's expecting any character that's not a hash because it's doing this skip none of because it's seen the bar character. But we want that inner parser to fail there. Not sure how we go about that. Is there a followed by parser or something? So we have the primitives in fparsec, which is what we want to have a look at. Let's make that a little bit bigger. So we're using choice to choose between a set of maybe attempt. Okay, I think this might be what we want. So the problem we have is that this parser doesn't just fail if you've got a bar and then a something that a bar and a hash, it moves past this character and then fails. So this needs to attempt that parser. Maybe? Yep. Looks good. So I'll stage those two, and we can rename this back to its proper name. Comments extended. So in this, it's going to, this should now parse correctly. So we should end up with a parse tree for it. It's telling us a snapshot does not exist. Fine. So there's no parse result for it. And this test is failing because reference to undefined symbol. Okay. I mean, it's not wrong. We don't have any support for these built-in symbols yet. What we could do, we don't support that kind of application or anything. It's only referencing equals and minus for the time being. We can just define those as being some kind of lambdas. So let's just put some, define that as a lambda that takes x and returns x. Not really what minus does, but hey, we don't need this to work. We just need it to, do we need this? Well, we're never actually calling fact, so that's fine. I mean, if those two procedures didn't actually do the right thing, then you could quite easily get into some kind of infinite recursion or something and then end up in a right state. Remove these when built-in are properly. Built-ins is going to be one of the next big things because it's difficult to do anything meaningful without actually having operators like equals and minus and multiplication, which we also need to define down there as well. If this hopefully they've both now failed because they don't have ill-formed define special form. Which one though? Yeah, I wanted these to be lambda special forms. Oh, no, that's not what I want. Just do it manually. Let's try and use multiple cursors there and be fancy, but when you've only got 3 lines to cover and you've already covered one of them, maybe you don't need to. Reference to undefined symbol equals. I'm not sure if this is something to do with the way that we parse symbols or something. Not quite working. Yeah, it's reference to undefined symbol. Binder. In the binder, what happens when we have a define? If you've got a define, it's got a body. If it is an ID, it just defines it. If this is an ID and a value, it defines the value. If it's a form with an ID and some formals followed by a body, it should do add binding for the ID. Let's debug that test. Find out. So it's in the spec tests. Discover. Confused here. I can mark that off. We've completed that. I think we've completed that as well. I just need to prove it actually works. It's compile and run, debug that test. Compile file is throwing an exception. So it's not even being able to run the file. That's the problem I was seeing, wasn't it? So here we are in parse file. Okay, we've got the breakpoint in the binder, so we should be able to see. This is going to be the bind of the first one. Can I see some locals, please? Debugger. Yeah, I can see some. So we've got the form, which is the I don't define foo. I don't think this is the right test because we're expecting fact. All right, let's just this one's bar. Don't care about this bit anymore. That's just lowering of the loop. This is minus, right? So we've got the ident minus and x. So we're going to add a binding to that storage. So now what does our storage contain? It's got one thing in it, which is the global. We're going to bind the lambda body inside that context. Okay. Oh, I know what this is. This is another issue, which is these definitions need to be inside this scope because we don't properly support scopes yet. So that should at least run now. So hopefully this will define all of these inside this lambda scope. 7 failures. I think the test task has crashed in an interesting way. There's dash A, no, L, .NET. So you got the compiler, background service, MS build, .NET test. Let's just kill those two. Ah, it's gone now. Now maybe we can run the tests again. I think the debugger was still running or something still attached to that. Or I'd left the tests in a bad state. This is what you... No. Let's just kill all then. Probably bits of Visual Studio Code that are now a bit broken now. Two failures though. Good. That's because the snapshot doesn't exist. And what about this one? This is looking a lot more like it's an actual reference to undefined symbol fact. That is... I mean, the problem here is that, again, fact is defined outside the scope of the lambda. Let's just hack it in again with another fix me. Still 2 failures. A snapshot did not exist. Right, we'll go through and we'll just set the update snapshot attribute. Then that should be it. In the spec tests, let it generate its snapshots. And then revert that. So parse comments extended is a sequence. The form of ident is defined fact, which is a lambda, which takes n, and defines the equals and the minus and the multiplication and the fact. So that's the shitload of shims, and then there's an if with an if n equals 0, return 1, and then there is a multiplication of n by fact n minus 1, and then everything closes off. That looks good. That's passed correctly, and the exit status is 0 because we don't actually return anything at the end, so it's going to be getting a unit. That's good. Right. Block comments are, that's not used block comments, is it? Block comments are pairs of and bar hash nested to an arbitrary depth. Right, so that's it for what I was planning to do on this stream. I hope it was interesting and informative, or just something something worth watching anyway. I'm not sure what the plan is going to be for the next stream, but those two issues we saw right at the end kind of point into the direction where the language needs the most work. We don't have any support for any of the built-ins at the moment, so instead of at the moment the only place we can store things is in the globals or in the locals, so we could add support for built-in symbols and lowering for things like times and divide and plus and minus, so that you can actually start writing some functions that use those. And the other thing is that we don't actually support proper nesting of scopes, so lambdas have all of their definitions in their scope, and the parent scope has its definitions, and that's all good, and those two are two separate things, but you can't reference things from a higher scope, and there's no support for things like lets and other kinds of syntactic definitions, bindings of variables and things. Tackling that would also mean tackling captures, maybe, so that could be an interesting place to go next. Anyway, thanks for watching, and I will see you next time.